Good afternoon, everybody. In yesterday's class, we discussed LAQs of binomial theorem. First, we discussed infinite series. Later, some different kind of questions when condition-based questions are given. Some more questions are there. So today I'm going to explain them. First question. If the coefficients of four consecutive terms in the expansion of 1 plus x whole to the power n are A1, A2, A3, A4 respectively. Then show that A1 by A1 plus A2 plus A3 by A3 plus A4 is equals to 2 into A2 by A2 plus A3. By taking the given condition, we have to prove this. Here expansion is given. What is given expansion? 1 plus x whole to the power n. Given expansion 1 plus x whole to the power n. In that, four consecutive successive terms are A1, A2, A3, A4. The coefficients of them are A1, A2, A3, A4. So here, in general, let four consecutive coefficients in 1 plus x whole to the power n are, we'll take this. First NCR, one term left side NCR minus 1, one term right side NCR plus 1. If you want one extra, NCR plus 2. These are the four consecutive coefficients in 1 plus x whole to the power n. What is given? Given that A1 is equals to NCR minus 1. A2 is equals to NCR. A3 is equals to NCR plus 1. A4 is equals to NCR plus 2. These values are given in the question. Now, go to the given data. LHS part we will take. LHS is A1 by A1 plus A2 plus A3 by A3 plus A4. This value we have to prove it as RHS. Take A1 common in the numerator, denominator. If we take A1 common, 1 plus A2 by A1 plus. In the same way, take A3 common in the denominator, 1 plus A4 by A3. A3 cancel, here A1 cancel. Substitute the value 1 by 1 plus A2 value NCR by A1 value NCR minus 1 plus again 1 by 1 plus A4 is NCR plus 2 by A3 is NCR plus 1. Simplify 1 by 1 plus, this we know the formula, n minus denominator suffix by numerator. Here also the same concept applies, 1 plus n minus r plus 1 by r plus 2 Now take LCM. 1 by LCM is R in the first term. So R plus, if we open up the bracket here, N minus R plus 1 plus 1 by, here again LCM is R plus 2. So R plus 2, open up the bracket, N minus R minus 1. R cancel, here also R cancel. Denominator R goes to numerator, R by N plus 1. Plus, here denominator R plus 2 goes to numerator, N plus 2 minus 1 is 1. Both denominators are same. So take common LCM, N plus 1. Add the numerator, R plus 2. R plus R is 2R plus 2 by N plus 1. Take 2 common, R plus 1 by 2 into R plus 1 by N plus 1. Take it as equation 1. Next, similarly, take RHS and simplify. RHS. What is our RHS? 2 into A2 by A2 plus A3. 2 into A2 as it is. Denominator A2 common. 1 plus A3 by A2. A2 cancel. 2 by 1 plus substitute values. A3 is NCR plus 1 by A2 is NCR. 2 by 1 plus, here simplified format, N minus R by R plus 1. Now take LCM. R plus 1 is LCM. R plus 1 plus N minus R. R cancel. 2 into this R plus 1 goes up by N plus 1. Take it as equation 2. By observing equation 1 and equation 2, both are same. So, with the help of 1 and 2, we can say that LHS is equals to RHS. The conclusion, therefore, from 1 and 2, we can write LHS is equals to RHS. What is LHS? A1 by A1 plus A2 plus A3 by A3 plus A4 is equals to RHS is 2 into A2 by A2 plus A3. Like how? We can prove the result. The given data we have taken as A1, A2, A3, A4 are 4 consecutive terms. They are NCR minus 1, NCR, NCR plus 1 and NCR plus 2. With the help of this, take an LHS and simplified. Just copy down. Link नहीं डाले ग्रुप में. Link. Next question. This is also one of the important questions. Before last year, this question has come for 7 marks. If n is a positive integer, prove that sigma R is equal to 1 to n R cube into NCR by NCR minus 1 whole square is equals to n into n plus 1 whole square into n plus 2 by 12. Simple question. Just by taking LHS, we have to prove it as RHS. Solution. Given expansion is sigma R is equals to 1 to n R cube into NCR by NCR minus 1 whole square. This is given. Sigma R is equals to 1 to n R cube into, expand with the formula, n minus denominator suffix by numerator suffix whole square. Implies sigma R is equals to 1 to n R cube. If we open the bracket, n minus R plus 1 whole square by R square. If we separate whole square, R square cancel. So left out part here, sigma R is equals to 1 to n, R is left out. In n minus R plus 1, first write n plus 1, then take minus R whole square. Treat first part is A and second part is B. It is in the form of A minus B whole square. Apply A minus B whole square here. Sigma R is equals to 1 to n R into A minus B whole square is A square plus B square minus 2AB. Sigma R is equals to 1 to n. Separate sigma and R to each and every term. R into n plus 1 whole square plus sigma R is equal to 1 to n. R into R square is R cube minus sigma R is equals to 1 to n 2R square into n plus 1. 2R square into n plus 1. Now, here R is a function, n is a constant. We'll write n term outside of the summation. So n plus 1 whole square will come out. So inside it is R is equals to 1 to n into R. Second term, there are no n terms. So let R cube as it is. In the next term, minus 2 into n plus 1, take it outside. Sigma R is equals to 1 to n R square. Now, n plus 1 whole square. Go on, expand sigma. R is equals to, substitute 1 to n values. Sigma means plus. So this is 1 plus 2 plus 3 plus so on up to n. Then plus. Second term is sigma R is equal to 1 to n R cube. So if you substitute 1 cube plus 2 cube plus 3 cube plus so on plus n cube minus 2 into n plus 1 into, expand sigma R is equal to 1 to n R square, 1 square plus 2 square plus 3 square plus so on plus n square. If you observe, 1 plus 2 plus 3 plus n is sum of n terms. Sum of n terms can be written as n into n plus 1 by 2. Here 1 cube plus 2 cube plus 3 cube is sum of cubes. So n square into n plus 1 whole square by 4. And here 1 square plus 2 square plus 3 square is sum of the squares of n terms. So formula for it is n into n plus 1 into 2n plus 1 by 6. So applying those values here, we will be getting n plus 1 whole square. Sum of n terms is n into n plus 1 by 2 minus R cube, sum of cubes, n square into n plus 1 whole square by 4 minus 2 into n plus 1 into sum of squares n into n plus 1 into 2n plus 1 by 6. So this part, instead of this bracket terms, I have applied the formula. Now try to take common. Every term have n and n plus 1 whole square by 2. Take this term common. So here left out is n plus 1 whole square has gone. Only n plus 1 left. By 2 also gone. And here one n left out, by 2 left out. And here minus 2 is there into 2n plus 1 by 3 left. Take LCM. N into n plus 1 whole square by 2. Here LCM is 6. So 6 into n plus 1 plus here 2 is there. 2 3s are minus 3n. Here 3 is there. 3 2s are 2. Already 2 is there into 2n plus 1. Open up the bracket. N into n plus 1 whole square by 2. Multiply with 6. 6n plus 6 plus 3n. 2 to the 4 to the 8n minus 2 to the 4 into 1 is 4 divided by 2. So finally we are getting n in by 6 it is. N into n plus 1 whole square into 6n plus 3n, 9n, 9n minus 8n, n plus 6 minus 4 is 2. By multiply the denominators, 2 6 the 12. This is what he is asking. So this is the given question. Just simplifying the given terms, we are getting the entire equation. Copy down the question. Move to the next question. This is another kind of important question. Take the question. If the coefficients of x to the power 10 in the expansion of ax square plus 1 by bx whole to the power 11 is equal to the coefficient of x to the power minus 10 in the expansion of ax minus 1 by bx square whole to the power 11. Then find the relation between A and B. Here what is he asking? Find the relation between A and B. Find the relation between A and B. By taking the coefficient of x power 10 in ax square plus 1 by bx whole power 11 and coefficient of x power minus 10 in ax minus 1 by bx square whole power 11 are equal. By taking this condition, we have to find the relation between A and B. So first, we'll take given expansion. First expansion we will take. Given expansion, ax square plus 1 by bx whole to the power 11. For finding coefficient of any term, we want general term first. General term. General term is what? TR plus 1 is equals to NCR x to the power n minus r into a to the power r. Substitute the values here. 11CR, x means first term, ax square to the power n is 11 minus r. A is 1 by bx to the power r. So 11CR, separate the power, a power 11 minus r into x square to the power 11 minus r into 1 by b power r into x power r. So 11CR, a to the power 11 minus r. Write the constant term together like b to the power r into x to the power what is there? 2 into 11, 22 minus 2 into r to r. If by x power r goes to numerator minus r. So TR plus 1 is equals to what we got? TR plus 1 is equals to 11CR a to the power 11 minus r by b to the power r into x to the power 22 minus 2r minus r is 3r. Take this is equation 1. This is only general term. What we want? We want coefficient of x to the power 10. So for that, first get x to the power 10 term. To get x to the power 10 term, equate x power to 10. What is x power? 22 minus 3r. 22 minus 3r is equals to 10. Bring 10 this side. 22 minus 10 is equals to 3r. 22 minus 10 is 12 is equals to 3r. So 12 by 3 is equals to r. Therefore, r value we got it as 4. Substitute r in equation 1. Substitute r is equals to 4 in equation 1. So 1 is TR plus 1. So T4 plus 1, that is nothing but T5 is equals to 11C4 a to the power 11 minus 4 is 7 by b to the power 4 into x to the power 22 minus 3 into 4. So here getting as T5 is equals to 11C4 a power 7 by b power 4 into x to the power 10. We got x to the power 10 term. Take it as capital I or Roman letter 1. By taking general term, we equated x power to 10 to get coefficient of x power 10 or to get x to the power 10 term first. After getting r value substituted in equation 1, we got T5. Next, take another expansion. In another expansion also the same. Coefficient of x power minus 10 we want. So here also go to the general term and simplify. Given expansion also. Given expansion. What is given expansion? Ax minus 1 by bx square whole to the power 11. Take general term. General term. Here careful, in between minus is there. In general term, TR plus 1 is equals to first minus 1 to the power R into NCR x to the power n minus R a power R. Substitute the value. Minus 1 power R, 11 CR, AX to the power 11 minus R, 1 by BX square to the power R. So, minus 1 power R into 11 CR, A power 11 minus R, X to the power 11 minus R, into 1 by B power R into X power 2R. Write constant terms together. So, minus 1 power R, 11 CR, A power 11 minus R by B power R. Similarly, bring all X terms together. X to the power 11 minus R by X power 2R if it goes up, power minus 2R. So, TR plus 1 is equals to minus 1 power R, 11 CR, A power 11 minus R by B power R into X to the power 11 minus 3R. Take this is equation 2. After getting this, which term we want? Coefficient of X power minus 10. So what to do? First, we'll find out X power minus 10 term. To get X to the power minus 10 term, equate X power to minus 10. X power to minus 10. What is X power here? 11 minus 3R is equal to minus 10. Bring minus 10 this side. 11 plus 10 is equals to 3R. 21 is equals to 3R. So R is equals to 7. R is equals to 7. Substitute R value in equation 2. Substitute R is equals to 7 in equation 2. So 2 implies T 7 plus 1 is equals to minus 1 power 7 into 11C7 into A to the power 11 minus 7 by B power 7 into X to the power 11 minus 3 into 7. So T7 plus 1 is T8 is equals to minus 1 power 7 is odd number. It is minus 11C7. A to the power 11 minus 7 is 4 by B to the power 7. X to the power 11 minus 21 is minus 10. Take this is capital Roman letter 2. Now apply the given condition. What is given condition? Coefficient of X power 10 and coefficient of X power minus 10 are equal. So apply that. But given that coefficient of X to the power 10 in equation capital 1 is equals to coefficient of X to the power minus 10 in Roman letter 2. In Roman letter 1, what is X to the power 10 term? What is X to the power 10 term? 11C4, A power 4, B, A power 7, B power 5. Only coefficient we want. So we don't want X to the power 10. 11C4, A power 4 by B power 7 is equals to, in equation 2, what is coefficient? Minus 11C7, A power 7 by B cube. Like this we got. So here simplify. 11C4 is 11 factorial by 11 minus 4, 7 factorial into 4 factorial. A power 4, A cube, B power, here it is B power 4, B cube. So what left here? 1 by B cube is equals to minus 11 factorial by 11 minus 7, 4 factorial into 7 factorial into A cube left out. This entire part get cancelled. Now cross multiply, keep minus to this side, minus 1 is equals to A cube, B cube. So A cube, B cube is equal to minus 1. A cube, B cube, we can write it as AB whole cube. Minus 1 also we can write minus 1 whole cube. Therefore, AB is equals to minus 1. He's asking the relation between A and B. So we got AB is equals to -1. Like how we have to derive. Just go through this question again. Next question. There is one more question of different type. P and Q, capital P and capital Q are the sum of odd and even terms. Odd and even terms of the expansion x plus a whole to the power n. X plus a whole to the power n. Then prove that first bit p square minus q square is equals to x square minus a square whole to the power n. Second bit 4pq is equals to x plus a whole power 2n minus x minus a whole power 2n. Here see, one expansion is given in that P and Q are the sum of odd and even terms he's telling. So first take the given expansion. X plus a whole to the power n. Expand nc0 x to the power n a power 0 plus nc1 x power n minus 1 into a power 1 plus nc2 x power n minus 2 into a square plus nc3 x power n minus 3 into a cube plus so on. Here nc0 is first term, nc1 is second term, nc3 is third term and nc4 is fourth term. So P and Q are sum of odd and even terms. So here what we have to do? Separate odd term and separate even term. Separate odd term and separate even term. First odd term is NC0 x to the power n a power 0. Next odd term is third term. This one, third term. NC2 x power n minus 2 into a square plus so on. Plus even term. So here write odd term. Odd term. Next, even terms. Even terms means second term. Like NC1 x power n minus 1 into a power 1. Next even term is NC3 x power n minus 3 into a cube plus so on. These are called what? Even terms. Is equals to what is given? P plus Q. So sum of odd and even terms are what? P and Q. So P is called sum of odd term and Q is called sum of even term. Next, similarly, take another expansion x minus a whole power n. In this, what are the odd terms? So first expand generally. Alternate terms you will be getting because minus is there. NC0 x power n a power 0 minus NC1 x power n minus 1 into a power 1 plus NC2 x power n minus 2 into a square plus minus NC3 x power n minus 3 into a cube plus so on. Here again separate odd and even terms. First odd terms are NC0 x power n a power 0 plus NC2 x power n minus 2 a square plus so on. Take minus common from even term. So that is NC1 x power n minus 1 into a power 1 plus NC3 x power n minus 3 into a cube plus so on is equals to what is given? P and Q. So it becomes P minus Q because in between minus is there. Sum of odd and even is P plus Q. The difference of odd and even is P minus Q. Now go to the first step. What is he asking? So this value is x minus a whole power n and this is x plus a whole power n. Go to the first bit. What is our first bit? We have to prove p square minus q square value something else. It is in the form of a square minus b square. So we can write it as p plus q into p minus q. We know p plus q is x plus a whole power n and p minus q is x minus a whole power n. Both powers are same. So put common power. We can write x plus a into x minus a. So it is in the form of a plus b into a minus b. So this goes as a square minus b square whole to the power n. Therefore, p square minus q square is equals to what we prove? X square minus a square by whole to the power n. This is how we have to go. In the same way, there is second bit. 4PQ value, something else you have to prove. It is in the form of 4AB. 4AB means P plus Q whole square minus P minus Q whole square. 4AB can be written as A plus B whole square minus A minus B whole square. Here 4PQ can be written as P plus Q whole square minus P minus Q whole square. P plus Q means x plus a whole to the power n whole square minus p minus q means x minus a whole power n whole square. So this is x plus a whole to the power 2 into n multiply 2n minus x minus a whole to the power 2 into n is 2n. Therefore, 4PQ value what we got? X plus a whole power 2n minus x minus a whole power 2n. This is how we have to prove. So if you want beside, you can write this formula. A 4AB can be written as a plus b whole square minus a minus b whole square. This format we applied here. So like how you have to solve the question of such kind of questions. So try to understand what is the term, what are odd terms, what are even terms. 1, 3, 5, 7 terms are odd terms. 2, 4, 6, 8 terms are even terms. So like that we separated and substituted in the formula. Just copy down them. So with this, I have completed the binomial theorem LAQ. In the next class, I will be going to explain a probability that will continue tomorrow. Thank you.